Chapter 1 Large Numbers Around Us. Ishwarappa is a farmer in Chintamani town in Karnataka. He visits the market regularly to buy seeds for his rice field. During such type of one visit, he heard the conversation between Chandramama and Ramanna. Ramanna said, earlier in our country had about 1 lakh varieties of rice. Farmers used to preserve different varieties of seeds and use them to grow rice. Now we have only a handful varieties, just few number. Also the farmer had to come to the market to buy seeds. Then Lakshma Mama said, there is a seed bank near my house. From there they can collect the different varieties of seeds. After that, Ishwarappa shared this incident with his daughter Rothsi and son Istu. Istu was surprised to know that there were about 1 lakh varieties of rice in this country. He wondered, 1 lakh. So far we tasted just 3 varieties only. So then he started to think, if we tried a new variety every day, each day, would we even come to close tasting all the varieties of in our lifetime of 100 years? We know that normal human lifetime is 100 years. So every day one variety, and in a year that will come 365 varieties in 1 year. In 100 years, 365 into 100, that will come 36,500 varieties only can taste in our lifetime of 100 years. But here 1 lakh varieties are there. So if we are trying with one item or one variety, one new variety in each day, in our lifetime we can taste only 36,500 varieties. But 1 lakh it is too high, big number. But how much is 1 lakh? We can see the pattern here. The largest 3-digit number is 9,999. Just 999. And the smallest 4-digit number is, just add 1 with 999, we will get the smallest 4-digit number. That means 1 and 3 zeros. When we are adding 1 with this number, we will get 1000. That is the smallest 4-digit number. Largest 4-digit number, which means 4 nines. 9,999. Again, smallest 5-digit number, that is 1 and 4 zeros. That is 10,000. That is the smallest 5-digit number. Now largest 5-digit number, 5 nines. 99,999. The smallest 6-digit number is 1 and 5 zeros. When we are adding 1 with this, we will get 1 lakh. Ones, tens, 100, 1000, 10,000, lakh, 1 lakh. 1 and 5 zeros, and this is the smallest 6-digit number. Now we can fill this table. 99,995, 99,996, then 99,997, 99,998, then 99,999. Then when we are adding one more, it will come 1 lakh. Then again adding 1. Next number is 1 lakh and 1. 1 lakh 1, then 1 lakh 2. 1 lakh 3. 1 lakh 4. Now again, Rotsy and Estu found they are thinking about that. If we are trying two varieties of rice every day, would we then be able to eat one like varieties of rice in 100 years? For that we can do the calculation like the same. 1 like we can write in digits like the same way, 1 and 5 zeros. So 1 like varieties of rice there. To taste all these varieties, one item or one variety in a day, then we need in 1 year, that means 1 lakh divided by 365 days in a year. So every day one item. So when we are dividing 1 lakh by 365, we will get 274 years. Approximate value 274 years, which means that normal lifetime, that is 100 years. So we can write, it is not possible to taste all these varieties in a lifetime of 100 years if we are trying one item or one variety in a day. Then they are thinking about two varieties of rice every day. So in a year, it will come 365 days in a year. Like that way, every day two varieties. So 365 into 2, 730 varieties can try in 1 year. Now this way, how many years we need to take to complete all these 1 lakh varieties? For that, to taste 1 lakh varieties, we have to divide that 1 lakh by 730. So we will get 137 years. That means if we are trying two varieties in each and every day, then also that will take 137 years to complete all these 1 lakh varieties. So again we can write that also not able to eat 1 lakh varieties of rice in a lifetime of 100 years. So if you are trying two varieties in a day also, we cannot finish all these 1 lakh varieties. Now they are thinking about three varieties of rice every day. Then we can finish in 100 years. If we are living in 100 years, then we can try or we can taste all these 1 lakh varieties if we are trying three varieties in each and every day. So we can think that way, three varieties of rice every day. Then in a year it will come 365 days, 1 day, 3 variety. So 365 into 3, 1095 varieties can taste in 1 year. So how many years we have to take to finish 1 lakh varieties? 1 lakh divided by 1095. We are getting 91 years. It's approximately 91. So we know that 91 is less than 100. 100 years normal life year if they are considering. Then 91 years means if you are trying three varieties in each and every day, then they can finish all the varieties in lifetime. So we can write in sentence here, they would be able to eat all 1 lakh varieties of rice in 100 years if they are trying three varieties in each day. Here we know, Istu said, we know how many days there are in a year, that means 365. Then if we live for y years, the number of days in our lifetime, that will be 365 into y. If we live 20 years, 365 into 20. That many days. If we live 50 years, then 365 into 50. Here the question, choose a number for y. How close to 1 lakh is the number of days in y years? For y of your choice. So we can first find, we know that is 1 lakh divided by 365 is equal to 273 years. So 365 into y, which means 365 into y years, that means here we are taking 273 years. That is equal to 99,645, which is almost close to 1 lakh. That means to get the y, the answer, we can take that as 273. If we are taking y as 273, then 365 into 273 is equal to 99,645 days. That will be close to 1 lakh. Figure it out. Page number 3. First question. According to the 2011 census, the population of a town, Chintamani, was 75,000. How much is less than 1 lakh? Is 75,000. So we can write that 1 lakh minus 75,000, we will get 25,000. We can write the answer like the same way. 1 lakh minus 75,000 people are there. So which is how much less than 1 lakh. So 1 lakh minus 75,000 is equal to 25,000. Second question. The estimated population of Chintamani in the year 2024 is 1,06,000. How much more than 1 lakh is that number? So we know that is 6,000 more than. We can write 1,06,000 minus 1 lakh is equal to 6,000. Third question. By how much did the population Chintamani increase from 2011 to 2024? In 2011, it was that means the population was 75,000, and in 2024 it became 1,06,000. So the difference between that 1,06,000 minus 75,000. 1,06,000 minus 75,000 is equal to 31,000. So the population in 2011, that was 75,000. In 2024 it becomes 1,06,000. The population increase from 2011 to 2024 is 1,06,000 minus 75,000 is equal to 31,000. Getting a feel of large numbers. Here, the Statue of Unity in Gujarat, its height is showing that about 180 meters. Statue of Unity. And Kunchigal waterfall in Karnataka, the height is about 450 meters. Now here Somu you can see standing here on top of that building, on the top floor, and Somu is 1 meter tall. Is having only 1 meter height. Each floor is about 4 times of his height. So this floor is 4 times of his height, which means 4 meter. Each floor is 4 meter. Now here, what is the approximate height of the building? Here we have to count how many floors are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 floors are there. So total 11 floors. So 11 into 4. Each floor is, his height is 1 meter, and each floor is 4 times of his height. Like that way 11 floors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 floors. So 11 into 44 is equal to 44 meter high is that building. Next one. Which is taller? Statue of Unity or this building? Statue of Unity 180 meter. This building is 44 meter. So we can say Statue of Unity is bigger. How much taller? So Statue of Unity, that is 180 meter. 180 minus 44, which is equal to 136 meter. So 136 meter bigger is Statue of Unity when we are comparing with this building. Next question. How much taller is the Kunchigal waterfall than Somo's building? Somo's building is 44 meter and this waterfall is 450 meter. So the difference is 450 minus 44, which is equal to 406. So 406 meter high is the difference between the waterfall and this building. Waterfall is 406 meter more. Now, how many floors should Somo's building have to be as high as the waterfall? Now, we know that the waterfall is 450 meter and this building is just each floor is 4 meter. So, how many floors required to make the same height as the waterfall? So, 450 divided by 4, we will get 112.5 something. So, we can write approximate 113 floors should be there in this building, then only that will reach almost the same height as the waterfall. Now we can write the answer same as that in sentence. Somo's height is 1 meter. So height of the floor, which means 4 into 1, 4 meter. Height of that building, 11 floors are there. So 11 into 4, 44 meter. Then Statue of Unity is 1 meter tall and this building is 44 meter tall. Difference in height is 180 minus 44, 136 meter. In sentence, Statue of Unity is taller than the building by 136 meter. Next, waterfall. So, waterfall is 450 meter and height of the building is 44 meter. The difference is 450 minus 44, that is 406 meter. So, waterfall is 406 meter taller than the building. Last question, each floor that we know 4 meter high. So how many floors required to make that 450? 450 divided by 4, 112.5. So we can take approximately 113 floors. That many floors to be as high as the waterfall. If the building is making 113 floors, then that will be equal to the height of the waterfall. Here a question, how do you view a lake? Lake is big or small? You can write that is a big number. Now reading and writing the numbers, 5-digit number. We know the 5-digit numbers we can read as 45,830. Now 1 lakh, 6-digit numbers. Here this number is coming 12 lakh 78,830. 15 lakh 75,000. Same way we can write the number name and also we can read the number. This one 3 lakh. We can mark that as ones place, 10, 100, 1000, 10,000 and this is the lakh place. So 3 lakh in 1000 and 10,000 place 0. So no need to say anything. Now in hundreds place 6. So 3 lakh 600. Here 5 lakh 4,085. 27 lakh 30,000. 70 lakh 53,138. Same thing that in words we can write like the same way. How we are reading, the same thing we can write in words. 3 lakh 600. 5 lakh 4,085. 27 lakh 30,000. 70 lakh 53,138. So this we can mark as ones, tens, 100, 1000, 10,000, lakh, 10 lakh. So this together. That's why this comma we are putting here. 70 lakh 53,138. 27 lakh 30,000. 5 lakh 4,085. 3 lakh 600. Write the corresponding number in Indian place value system for each of the following. First one, 1 lakh. 1 lakh 23,000. 23,456. 456. So 1 lakh 23,456. Next one, 4 lakh. 4 lakh. 7,000. So 10,000 place is nothing is given. So we have to put 0 there. 0, 7. 7,704. 704. Tens place and 10,000's place, no digit. So we have to put 0 there. 4 lakh 7,704. Next one, 50 lakhs. 50. Then 5,000. 0, 5. Then 50. Hundreds place nothing. So it will come like the same way. 50 lakh 5,050. 10 lakhs. 235. So in 1,000 and 10,000 place zeros. 235. 10 lakh 235. Thoughtful thousands only has a 1,000 button, plus 1,000. How many times should it be pressed to show? 3,000, for that 3 times you have to press. 1,000 plus 1,000 plus 1,000. 3 times, then we will get 3,000. For 10,000, how many times? So 10 times. For easily we can think that is these 3 zeros will cancel. Table of 1,000. So just cancel, we will get the answer. 53,000. So 53 times. 53,000 is the number. To get that, cancel these 3 zeros, we will get the answer as 53 times we have to press that. Here for 90,000, we will get the answer 90 times we have to press. 1 lakh. 1 lakh is the number with 5 zeros. So 1,000, here 3 zeros, cancel these 3 zeros. Then we will get that as 100 times. If we are pressing 1,000 button, we will get 1 lakh. Here 153 times. So 153 times multiplying or taking this 1,000 into 1,000 will come 1,53,000. How many thousands are required to make 1 lakh? So 1 lakh to make that is 100 thousands. Now with the tens button, how many times should it be pressed to show 500? We know that 500 is the number, this one. So using tens button, how many times? Cancel 1 0, we will get the answer 50 times. So we have to press 10. So 50 into 10, we will get back that 500. To get 780, 1 0, then 78 times. To get 1,000, 1 0 you have to remove, then 100 times. 3,700, remove 1 0, we will get 370 times. 10,000, to get that number, we have to press 10,000 times. Just remove 1 0 from a unit place. Remaining number will be the answer of that. 1 lakh. 1 lakh we know that 1 and 5 zeros. From there 1 0 when we are removing, we are getting 10,000 with the 4 zeros. That we can write as 10,000. Now for 35 times when we are pressing 10. So 435 into 10. 435 into 10. That means 435 and put the 0. 4,350 you will get the answer. Here the 100 but plus 100 is the button. How many times should it press to get 400? 400 means this is the number. So by 100 or remove the 2 zeros. 100 having 2 zeros. So just 2 zeros when you are cutting, we will get 4 times to press. When we are pressing 4 times 100, it will come 400. 4 into 100, 400. Now here to get 3,737 times. Similarly here, to get 10,000, 2 zeros you have to remove, so 100 times. 53,000, 53,000, first you have to write the number like the same, 53,000, and pressing 100 is the button. So 2 zeros are there for the 100, here also 2 zeros you have to remove, then 530 times. Here by 100, that means 900 times we had to press. To get 97,600, we had to press 976 times. To get 1 lakh, we had to press 1000 times. And if you are pressing 582 times, that means 582 into 100. It will come 582 and 2 zeros more. That means 58,200. Next question, how many hundreds are required to make 10,000? So 10,000 is the number. How many hundreds are required to make 10,000? So 10,000 is the number. How many hundreds means just to remove 2 zeros, it will come 100. The answer is 100. How many hundreds required to make 1 lakh? 1 lakh is the number with 5 zeros. Remove 2 zeros from that. Then remaining 1000. So 1000 hundreds make 1 lakh. Handy 100 says there are some numbers which are tedious tens and thoughtful thousands cannot show, but I can. Is this statement true? Think and explore. So each and the number, which one we can express in terms of 100, for example 700. So that we can represent by multiples of 10 also, 70 into 10. So multiples of 100 we can replace by multiples of tens. So that statement is not true. Here these are the buttons 1, 10, 100, 1000, 10,000, 1 lakh and 10 lakh. It always has multiple ways of doing this. So the number 321. 321 we can write as here 32 times 10, 320. 32 times 10, which it will come 320. That plus 1. One time that 1 but plus 1 button. So it will come 321. Another method, it can press 100 keys 2 times. 100 keys alternative, it can press 100 2 times, and so it will come 200, and 10 12 times, so that will come 12 into 10 120, then plus 1, that also we will get 321 days. So will it get 321? Yes. Fifth question, two of the many different ways to get 5072 are shown below. 50 into 100, it will come 5072. 5072. Here 3 into 1000, 3000. 20 into 100, it will come 2000. So 3 plus 2, 5072. Now find a different way to get 5072 and write the expression for the same. We can write easily that as 5 into 1000 plus 7 into 10 plus 2 into 1. So 5000, it will come 5000 plus 70 plus 2. If we are marking here 1000, here 5000. 7 times 100. So 5000. 1000 is here, so we have to mark here only. 5700, 5072, not 700. 5 into 1000, then 7 into 10. 7 into 10, 2 into 1. So 5072 is the method. Here, figure it out, page number 6. For each of the number given below, write the expressions for at least two different ways. First number is 8300. So this we can write 8 into 1000 plus 3 into 100. Another one 83 into 100 also we will get the same. Or 8 into 1000 plus 30 into 10 also it will come. So different way we can write. Here that's some two different ways here. 8 into 8300, 8 into 1000 plus 3 into 100, or 83 into 100. Next number 40,629. This much 1000. So 40 into 1000. 6 in hundreds place, 6 into 100, 2 in tens place. So we can mark that as unit place or ones place. 10, 100, this is coming in 10,000. So 40 together, 40 into 1000, 6 into 100, 2 into 10, 9 into 1. We will get 40,629. Another method, if you are taking 4 only here, then 4 in 10,000 place. So 4 into 10,000 plus 6 into 100 plus 29 into 1. Next number 56,354. That we can write as 5 into 10,000 plus 6 into 1000 plus 3 into 100, 5 into 10 plus 4 into 1. Another method 56 together, 56 into 1000, 35 together, 35 into 10 and 4 into 1. The next number is 66,666. That we can write 6 into 10,000. Then 6 into 1000, 6 into 100, 6 into 10, 6 into 1. Another method, if you are taking 66 together, 66 into 1000, 66 into 10, then 6 into 1. Next number 3,67,830. 3,67,830. So 3 into lakh. Then 6 into 10,000. 7 into 1000. 8 into 100. 1 into 10. 3 into 1. Ones, tens. 8 into 100. 7 into 1000. 6 into 10,000. 3 into lakh. If you are taking two digits together, 36 into 10,000, 78 into 100, 13 into 1. Here the question, you have to make exactly 30 button presses. Here we can see all the buttons. 30 times we have to press and make the largest 3-digit number. What you can make and what is the smallest 3-digit number. So we know that largest 3-digit number is 999. Smallest 3-digit number is 100. But there's a condition. We have to press 30 times. Any of these buttons 30 times we have to press. That's the way we have to calculate and find out the largest 3-digit number and the smallest 3-digit number. We can do this way. For the largest 3-digit number, 9 times that 100 button. So it will come 900. 8 times 10 button and 13 times 1 button. So here we are getting 900, 8 into 10, 80, then 13. So 980 plus 13, 80 plus 13, 93. So 993 we will get. Also we have to check the number of times the button pressed. 9 times 100, 8 times 10, 13 times 1. So 9 plus 8 plus 13 we have to get 30. Now when we are adding all the number of presses is equal to 30. So this is one of that method. That means the largest 3-digit number by using 30 times the button press, we are getting as 993. Similarly, the smallest 3-digit number. For that, 8 times plus 10 button. 22 times that 1 button. Then only we will get 8 plus 22. 8 plus 22, 30 times is coming. So total number of button press, that is 30, that is matching. And the number, here 8 into 10, 80. 22 into 1, 22. So 80 plus 20, 100. 80 plus 22, 102. That also correct. So smallest 3-digit number by using 30 times the button press, we are getting the smallest number as 102 and the largest 3-digit number as 993. Now the next number, 997, can be made using 25 clicks. So 997, we can make 9 into 100 plus 9 into 10 plus 7 into 1. So 9 plus 9 plus 7 is equal to 25 click. 25 times we are clicking the buttons, and when we are adding the number 900 plus 90 plus 7, 997 we will get. So we can make by 25 clicks. Again the question, can you make the same number 997 with a different number of clicks? We can try with another number of clicks, 34. 9 into 100, 8 into 10, 17 into 1. So 9 plus 8 plus 17, we are getting 34 clicks. The number is 980 plus 17. So 997 we will get. So we can write, yes, we can make with the 34 clicks also. How can we get the numbers 5072, 8300 using a few button clicks as possible? 5072, we can, it's already given 5 times 1000, 6 times 10, so 5000 and then 60, here 12, 72, so 5072. Another method, 5000, so 5 here, then 70, 7 times 10 and 2 times 1. So it will come 5072. 8300, 8 times 1000, 3 times 100. So 8300. Figure it out, page number 7. For the numbers in the previous exercise, find out how to get each number by making the smallest number of button clicks and write the expression. Previous exercise means the previous page here. These numbers. These numbers we can write as first number 8300. So that we can write as 8 into 1000 plus 3 into 100. 1000 button 8 times, 100 button 3 times. So number of click, that means 8 plus 3, 11 clicks. Next 40,629. 4 times 10,000 button, 6 times 100 button, 2 times 10 button and 9 times 1's button. So the number 4 plus 6 plus 2 plus 9, 21 clicks to get this number. Next is 56,354. 5 times 10,000 button, 6 times 1000 button. This is the place values. 3 times 100 button, 5 times 10 button, 4 times 1 button. So total number of click, that means 5 plus 6 plus 3 plus 5 plus 4 is equal to 23 clicks. Next number 66,666. So 6 times 10,000 button, 6 times 1000 button, 6 times 100 button, 6 times 10's button, 6 times 1's button. When we are adding all that, we will get 30 clicks to get that number. The last number in that exercise 3,67,813. So 3 into 1 lakh, 6 into 10,000, 7 into 1000, 8 into 100, 1 into 10, 3 into 1. So when we adding the number of clicks is equal to 28 clicks there. Second question, do you see any connection between each number and the corresponding smallest number of button clicks? So we can write the connection as here. It depends on the place value of the digit in the number. Actually, it is the place value of that each digit. If the digit in the number is small, then the less number of clicks. If it is bigger number, then the number of clicks are more. Third question, if you notice the expressions for the least button clicks, also give the Indian place value notation of the numbers. Think about why this is so. That according to the place value, the number of clicks, the least number of clicks is coming. For example, 7,682. So this in thousands place. Ones, tens, hundred. So least number of clicks of the button click, it is coming according to the place value. Indian place value. So 7 into 1000, 6 into 100, 8 into 10, 2 into 1. So that's the way when we are clicking the number we will get. The buttons when we are clicking like this order we will get. So it's based on Indian place value notation. Cross and cross. Here we can see the Indian system and American system. American system is also called as international system. American system or international system. This one it is Indian system. When we are comparing, we can see till that 10,000 both are same. 1,000, 10,000 both are same. After that 10,000, in Indian system, we are moving grouping with the 2 digits. 1 lakh, 10 lakh, 1 crore, 10 crore, 1 Arab, like that it is going on. So group of 2 is coming here. But in American system or international system, that is coming again continuing with the same way, grouping of 3 digits. So after 10,000, next is 100,000. Then after that 1 million, 10 million, 100 million. Till the 3 digit group. After that it will go to the next 1 billion. 1 billion contains here 3, 6, 9 zeros. That the same number in Indian system, that is called 1 Arab or 100 crores. So till that 10,000 place both it is same till this place, and then it is going changing the terms. Here 1 lakh, in place of that 100,000, like that. The numbers is here we can write from ones place. In Indian system it is going ones, tens, 100,000, 10,000. International or American system, they are also same way it is going on. Ones, tens, 100, hundreds, 1,000, 10,000. Till here it is same. Both the number system is going the same way. Ones, tens, 100,000, 10,000 till here. Then the names, number names it is changing, or the reading also is changing according to that. Here we can see in Indian system, lakh, 10 lakh, crore, 10 crore, and 1 Arab. 1 Arab, or that also it's called 100 crore. So here everywhere we can see it's grouping of 2, except this first group. But in international system or in American system, everywhere group of 3 they are making. After 1,000, 10,000 they are making that as 100,000. So group of 3. Then after that the next group is forming. 1 million. So group of 3 and then 1. 10 million, 100 million. Again that after that group of 3, then next number 1 billion. That 1 billion is same as our 100 crore. 10 crore, that is equal to 100 million. Or 1 million is same as 10 lakh. For fill in the blanks, it will come. So dash lakh, or that is equal to million, billion, and that all. So comparison is important. 1 million is equal to 10 lakh. Here the question, how many zeros does a 1000 lakh have? 1000 lakh, that means 1000 here and then lakh also. Lakh already having 5 zeros. So, or we can multiply that 1000 into 1 lakh. So when we are multiplying, we will get 1, and here 3 zeros plus 2, 5 zeros in lakh, and in 1000 3 zeros. So total it will come 5 plus 3, 8 zeros. 8 zeros. So we can write how many zeros? 8 zeros. In 1000 lakh. How many zeros does a 100,000 have? 100,000. So here we can see 3 plus 2, 5 zeros. 5 zeros. Here to read big numbers, we are putting the commas to read easily. Easily read by placing the commas first. So when we are putting the commas, the first group with the 3 digits, rest of that from right to left 2 digits. So in Indian system, we can read this as 9 Arab 87 crore 65 lakhs 1234. The same number in American system, we had to group with 3 in each, 3 digits in each group. So it will come 9 billion 876 million 501,234. Same way, the first question, figure it out, page number 9. Read the following numbers in Indian place value notation and write their names both Indian and American system. So in Indian place value notation, first we have to place the comma in between. So it will come 40 lakh 50,678. Next one, 4 crore 81 lakh 21,620. Here 2 crore 22,002. 24 crore 68 lakh 13,579. 34 crore 50 lakhs 543. 1 Arab 2 crore 3 lakh 4,050. So this is the number name, or how to read the number. Now we have to write all these numbers in Indian place value, both Indian place value and American system. The first number in Indian system, that is marked with I here, Indian system, this American system. 40 lakh, group of 2 from here. 40 lakh 50,678. In American system, it will come 4,050,678. Next number, in Indian system, 4 crore 81 lakh 21,620. In American system, 48,121,121 4,620. Next number here, in Indian system, 2 crore 22,002. American system, 20 million 22,002. Next one, in Indian system, 24 crore 68 lakh 13,579. In American system, 246 million 813,579. Then the next number, in Indian system, 34 crore 50 lakh 543. In American system, 345 million 543. The last one, in Indian system, this number, in Indian system, 1 Arab 2 crore 3 lakh 4,050. In American system, the same number, 1 billion 20 million 304,050. So Indian, according to Indian system and international or American system, the number name of these numbers. Second question, write the following numbers in Indian place value notation. 1 crore, 1 lakh, 1,000, then 10. So 1 crore, 1 lakh, 1,000, 10. Next one, 1 billion. So this in international price value system. 1 billion. Then is coming 1 million. That means 2 zeros and 1. 1 million. Then again 1,000. 0, 0, 1. 1,000 and 1. So 1 billion, 1 million, 1,000, 1. Next is 10 crore. 10 crore, 20 lakh, 30,000, 40. 9 billion. 9 billion, 80 million, 0, 80, million, 700,000, 600. Compare this with the less than, greater than or equal to sign. Here 30,000 and 3 lakhs. We know that 30,000 is less than 3 lakh. 30,000 is less than lakh, so less than sign. Here 500 lakhs and 5 million. So 500 lakh, we know that 1 lakh is equal to 100,000. So 10 lakhs, that is equal to 1 million. Here 500 lakhs. So it will become 500 lakhs, that is greater than 5 million. 800,000 and 8 million. So 8 million is bigger. 640 crore and 60 billion. That also 60 billion, that is more. Nearest neighbors. Here the number 6 crore 72 lakh 85,183. Nearest 1000, that number to the nearest 1000. So we have to think about these three numbers, this digit, hundreds place digit. That is 1, which is less than 1, we can ignore that. So 6 crore 72 lakh 85,000. That is the rounding off to the nearest 1000. The nearest 10,000, this 85 to 10,000, we have to look at the thousands place. Here 5 or more than 5. That means 5, 6, 7, 8, 9. These digits are coming in thousands place, we have to take the next 10,000 multiple. This 85,000 lies between 80,000 and 90,000. Between that, 85 is coming in between. So if your thousands place digit is 5 or more than that, we have to take the next number, round off to the next number. So it will come 6 crore 72,090. 6 crore 72 lakh 90,000 to the nearest lakh. So we have to think about this digit 9. Just one place down, that means lakh means 10,000s place digit. 9, that is greater than 5. So we have to think the next number. Here 72, it will come 73. 6 crore 73 lakh. This number lies between 6 crore 72 lakh and 6 crore 73 lakh. So it's 9. It is going to the next one, close to 6 crore 73 lakh. Then to the nearest 10 lakh. Think about this lakhs place digit 3. So 3 means less than 5, that we can ignore. So it will come 70. In place of 73, it is coming 70. Rest of the digits same. 6 crore 70 lakh. Nearest crore. Then we have to think about 10 lakhs place. 7. 7 is greater than 5. So this 6 in place of that, we have to take the next number 7. So this number lies between 6 crore and 7 crore. Here 7 more than 5. So you have to take that as near to 7 crore. This is the way we have to round off the numbers. Similarly, write the 5 nearest neighbors for these numbers. Here 3 crore 87 lakh 67,957. First we are going to write to the nearest 1000. So we can delete this one, and here the digit is 9. So it will come to the next number in between 69,000 and 70,000. So 9 means we have to take the 70,000. So 3 crore 87 lakh 70,000. The same way we can write both the numbers here. So here we can see to the nearest 1000 it will come 70,000. 10,000. So you have to consider thousands place, that is 0, less than 5. So we had the same thing, it will come. These digits same. Now to the nearest lakh. Lakh means we have to consider the 10,000, one place less. 10,000 place digit, that is 7. 7 is greater than 5. So this number lies between 87 lakh and 88 lakh. Here 7 is more than 5. So we have to take 88. 3 crore 88 lakh. Then 10 lakh. To consider lakhs place digit. This number lies between 80 lakh and 90 lakh. Now nearest to 90. 3 crore 90 lakh. Then to the nearest crore. 10 lakhs place digit 9. So this number lies between 3 crore and 4 crore. So close to 4 crore. Same way this number. To the nearest 1000. Here 4. 4 is less than 5. See the rounding of that digit is 0, 1, 2, 3, 4. Then we can ignore that, take the previous number. If it is 5, 6, 7, 8 or 9, any one of these digits in that place, we have to take the next number. Here this number, if you are considering only this much, number lies between 32,000 and 33,000. But here 4, it is coming here. So we can ignore that. We will write that as 32,000. These digits same here. When we are taking 10,000, nearest 10,000. So it is coming, you have to take this digit. That also coming in this group. So we can ignore that. This number 32,000 lies between 30 and 40,000. So we are taking 30,000. Next, like. So we think about this one. That also in this group, less than number. So we can ignore that. Rest of the digits same. 29 crore, 5 lakh. Then here 5 is coming. So you have to take the next one. 29 crore, 10 lakh. Again here 1 we can ignore. So it will come 29 crore itself. So this is the way we have to round the numbers. Here I have a number for which all 5 nearest neighbors are 5 crore. What could be the number be? How many such numbers we can take it? If we are considering 4 crore, 99 lakh, 99,999. If we are considering this number, when we are taking nearest 1000, 10,000, lakh, 10 lakh, crore, everything, it will come to the same answer, same number as 5 crore. Now here, Rothsey and S2 are estimating the value of simple expressions. Here two numbers are there given. The actual value, when we are adding these two numbers, we will get that as 8 lakh 82,810. So directly when we are adding, we are getting 8 lakh 82,810. Now Rothsey saying the sum is near to 8 lakh and is more than 8 lakh. That means 8 lakh or more than 8 lakh. Here S2 is saying the sum is near to 9 lakh or less than 9 lakh. Now, are these statements correct? Whose statement is closer to the sum? So when we are taking the estimated sum, this one is close to 9 lakh. 8 lakh 82,000. So when we are considering this as 8, it will close to 9,000. Sorry, 9 lakh. 9 lakh. So we can write it here. Yes, S2's statement is correct. S2's statement is closer to the answer. Now, will the sum is greater than 8 lakh 50,000? Yes. So it's greater than 8. We got the answer is 8 lakh 82,800. That is greater than 8 lakh 50,000. Then will the sum be greater than 8 lakh 83,128? 8 lakh 83,128. Here we got 8 lakh 82,000 only. So that is less than 8 lakh 83,000. We got only 82,000 here. Here 82, so we can take that as less than that number. Then the exact value, already we wrote it here, exact value, that is 8 lakh 82,810. Same way the second question. Here the numbers 14 lakh 63,128 minus 4 lakh 90,020. So when we are minusing, we are getting that as 9 lakh 73,108 we will get. But the approximate value, when we are taking estimated value, so the actual difference between these two numbers, that is 9 lakh 73,108. The estimated, it will come here 73,000. So that we can take that as nearest to lakhs place. So it will come in between 9 lakh and 10 lakh. So we can take that as 10 lakh. The round figure is 10 lakh. Now the difference, they are saying, Rothsey is saying the difference is near to 10 lakh and less than 10 lakh. S2 is saying the difference is near to 9 lakh and more than 9 lakh. So here the answer is coming more close to row C. That means almost near to 10 lakh and less than that. So the estimate is correct. Whose estimate is closer to? So we can write that as row C. Our estimate is almost close to the correct answer. Then, will the difference be greater than 9,50,000? Yes, it's greater than 9,50,000. So we can write yes, greater than 9,50,000. Why do you think so? So when we are taking here the difference, we are getting 9,73,108, which is greater than. So 9,73,108, that is greater than 9,50,000. The exact value between these two numbers, what we got, that is 9,73,108. So here the question, will the difference be greater than 9,63,128 or less than 9,63,000? So that is greater than. We got 9,73,000, that is greater than this number. Here population of cities. Observe the population of some Indian cities in the table below. Population in 2011 and 2001. So we can see the increase in population each and every city. And based on that, here the question. From the information given below, given in the table, answer the following questions by approximation. What is your general observation about this data? So the general observation, we can say that the data showing the population of Indian cities in years 2001 and 2011. What is an appropriate title for the above table? We can give the title population of 20 Indian cities in 2001 and 2011. How much is the population of Pune in 2011? Pune, here we can see 31,15,431. And in 2001, it is coming 25,38,473. So the approximate increase, approximate means we have to take round of the number. So we can take that as 31 lakh and 25 lakh. So around 6 lakh difference increase is coming there. So we can write that population of Pune in 2011, that is 31 lakh 15,431. The rounded number, it will come 31 lakh. Rounded number 25 lakh, difference is 6 lakh. Previous question, the heading we can give population of 20 Indian cities in 2001 and 2011. The data shows the population of Indian cities in years 2001 and 11. Fourth question, which city's population increased the most between 2001 and 11? Bangalore experience the largest population increase in between these years. Fifth question, are there cities whose population has almost doubled? Which are they? So we have to see the table and find the difference between these two years, 2001 population with the 2011 population. Then we can see Bangalore, Hyderabad, Surat, Vadodara and Pimpri Chinchwad. These are the cities, almost nearly double their population. Next question, by what number should we multiply Patna's population to get Mumbai's population? So for that, first we have to write Mumbai's population, that by Patna's population. So when we are dividing, we will get approximate 7. So we can write Patna's population, we have to multiply with 7 to get Mumbai's population. Patterns in products. Multiplication in shortcut. So here the question 116 into 5. With multiplication with 5 is we have to do the calculation work. At the same time, any number with 10, that will be easy. So 5 we can write as 10 by 2. 5 we can replace as 10 by 2. So 116 into, in place of 5 we have to write 10 by 2. Then when we are cutting this or dividing by 2, here 58, and that into 10 we will get 580. Any number into 10, just write the number and put 0 on the right side. So 580 is a shortcut method. Similarly here 824 into 25. 25 is same as 25 we can write as 100 by 4. So 100 by 4 is 25. So we can replace this 25 with 100 by 4. After that, divide both the numbers with 4. We'll get 206, and that into 100 means 2 zeros. We have to put on the right side of that number. 206 and 2 zeros. So you'll get easily the answer. Using the meaning of multiplication and division, can you explain why multiplying by 5 is the same as dividing by 2 and multiplying by 10? Multiplying by 5, that means we can write 5 is equal to multiplying by 10 and dividing by 2. Multiplying by 10 and dividing by 2. So it is same. Multiplication factors are 2 into 5 is equal to 10, or 10 by 2 is equal to 5, using the division facts. Figure it out, page number 14. Find quick ways to calculate these products. Here 1768, 2 and 50. First we have to multiply 2 into 50. We will know that 2 into 50 is equal to 100. So we can write this number 1768, that into 2 into 50, 100. So which is equal to, write the same number 1768 and put these 2 zeros. When we are multiplying with 100, add 2 zeros on the right side. So we can read the number as 1,76,800. Here 72 into 125. 125 we can replace that as 1000 by 8. So 72 into, in place of 125 we are writing 1000 by 8. 1000 by 8. Here 8 and 72 we can divide. 9 times 8 is equal to 72. So 9 into 1000, we will get the answer 9000 without doing any multiplication work. Here the next one. 125 we can write that as same as 1000 by 8 into, then 40 into 8 into 25 we can write as 100 by 4. Now this 8 and 8 will cancel. 4 and 4 will cancel here, or 10 times 4 in 40. So we are getting here 1 and 3 zeros. Here 1 0. Here 2 zeros more. So the answer is 10 lakh. Second question, calculate these products quickly. 25 into, we can write 12 as 4 into 3. So 25 into 4, it will come that is 100. That into 3 is equal to 300. Here 25 into, you can split 240. That is 4 into 60. 25 into 4, 100. 16, 100 into 60, which is equal to 6000. 60 and then 2 zeros more. Next one, 250 into 120. So 250 into 4 into. Here when we are taking 4 out, then 4 into 120 we can split as 4 into 30. So this already 250 into 4, that will come 1000. 1000 into 30. is equal to 30,000. Next one, 2,500 that into 12. 4 into 3. This will come 10,000. That into 3 is equal to 30,000. Here 12 crore. 12 crore. To get that number, easily we can write that as 20,000 into 6,000. So 2 into 6, 12. Zeros, 4 plus 3, 7 zeros. 2, 4, 7 zeros. So we can split that number as 20,000 into 6,000. So without the multiplication process, we can straight away, in shortcut method, quickly we will get the answers. Multiplication, and also this one of the method by dividing, converting 125 was 1000 by 8, 25 was 100 by 4, and 5 was 10 by 2. Or by splitting 12, 24, etc. If we are getting in this side 25, 25 into 4, 100, 250 into 4, 1000, 2500 into 4, 10,000, like that way. Now look at the pattern. Evaluate them to find the pattern. Extend the multiplication based on the observed pattern. So 11 into 11, we know that is 121. 111 into 111. It will come 12,321. 12,321. Now we can see 1, 2, 1. 1 is going increasing and coming down. 1, 2, 3. Then from there 3, 2, 1. Now here the same 4 digits are there. So it will come up to 4. 3 digits multiplication up to 3. 2 digit up to 2. So here up to 4. 1, 2, 3, 4. Then the same way we had to put it down. 3, 2, 1. Increasing order, then decreasing order. If you are putting one more digit here, 4 digits are here. Then 1, 5 here. Then we had to move up to 5. 1, 2, 3, 4, 5. Then decreasing. 4, 3, 2, 1. That will be the answer of that. Now next one here. 66 into 61. Here the answer is 4026. Next number, the answer we are getting 44. Then 0. 22, 6. Here we can see 4 is doubling, 0 is there, 2 also is doubled there. The next number, when it becomes one more time, here 6 is 2 times repeated. Now here is going 3 times. So here also it will come 4 3 times. And then 0. Again 2 3 times. Then that's 6. The next number when we are writing here 4 6s are there. Next when we are writing 5 6s. Into here 3 in place of that 4 will come. Into 1. There 4 times 4 will come. Here 3 times. Next is 4 times 4. And then 0. Again 2 4 times. And then 6. It is going on like that way. Here in this pattern, 3 into 5, 50. 33 into 35. Here both the digits are repeating. 1 1 5 5. Now again one more time. So that is coming 3 times. 3 1s, 3 5s. Then next if you are continuing, here 1 time, 2 time, 3 times, so 4 time. Into here 1 time 3, 2 time 3, then 3 time 3. C equal to here 3 time 1. So next it will come 4 time. 5 time. sorry, 4 times 5. Like that way. It will continue. Next 101 into 101. Here we are getting 10,201. The next number it will come 10,404. 10,004 in place of that 404. Next it is coming 10,609. So the next number is here 104 into 104, which is equal to 10,816. 816. That means this middle digit, this is doubled. 2 becomes multiples of 2. 2 becomes 4, 4 becomes 6, 6 becomes 8. Here this one it is coming, first one is 1 only, and the next it is coming 4, then 9, then 16, etc. Square numbers. So that also will continue like the same. Here observe the number of digits in the two numbers being multiplied and their product in each case. Is there any connection between the numbers being multiplied and the number of digits in their product? Yes. Rothsey says that the product of two-digit numbers can only be a 3 or 4-digit number. Is she correct? Yes. Two-digit number into two-digit number, we will get 3-digit number or 4-digit number. For example, here, should we try possible multiplication with the two-digit numbers to tell Rothsey's claim true, or there is a better way to find out? Yes, there is a better way. That means the smallest two-digit number, that is 10. 10 into 10, we are getting 100. It's a 3-digit number. The highest two-digit number is 99. 99 into 99, we are getting 9,804. That means 4-digit number. So we know that the smallest two-digit numbers, when we are multiplying, we are getting a 3-digit answer or product. The highest two-digit numbers multiplying, we are getting 4. So 3 or 4, what she said, it's correct. Be a 3 or 4-digit number. Can multiplying a 3-digit number with another 3-digit number give a 4-digit number? No. Can multiplying 4-digit number with a 2-digit number give a 5-digit number? Yes. Here the number will be 5 or 6-digit number can be. Here 3-digit by 3-digit, it will come 3 plus 3, that means 6. So 5 or 6 there also. It can be not 4-digit number. Now observe the pattern and do you notice the pattern? See if this pattern extends for other as well as 1 digit into 1 digit, 1 or 2. 2 into 1, 2 or 3. 2 into 2, 3 or 4. 3 into 3, 5 or 6. 5 into 5. First you have to add the digits. 5 plus 5, 10. 1 less, 9. Here also 3 plus 3, 6. 1 less, 5. 2 plus 2, 4. 1 less, 3. 2 plus 1, 3. 1 less means 2. 1 plus 1, 2. 1 less that 1. So this or that will be the number of digits in the product. Here 8 and 3-digit numbers. 8 plus 3, 11. So the product be 11-digit number or 1 less of that 10-digit number. 12 plus 13. So when we are adding, we are getting 25. So the number can be, the product contains the digits, number of digits in the product be 25 or 24. So the pattern in general we can write if there are n number of digits in the first number n and the second one, that is m. First number with n digits, second number with m digits. In general, the product will give, that means n plus m. digits, or that n plus m minus 1, that many digits. This is the rule. If the number of digits in the multiplier, that means the numbers as n and m, then the product, number of digits in the product, that is same as add the number of digits, n plus m digits, or 1 less than that. Here 5 plus 5, 10 digits in the product or 9 digits. The RMS Titanic ship carried about 2,500 passengers. Can the population of Mumbai fit into 5,000 such ships? So that ship contains 2,500 passengers. Population of Mumbai, the previous page we noticed that population of Mumbai, that is 1,24 lakh. So in one ship 2,500 passengers. Like that way 5,000 ships. It will come 2,500 into 5,000, 1,25 lakh. So in Mumbai population 1,24 lakh only. So we can write yes, Mumbai population can fit easily into 5,000 such ships. Here Rothsey wondered if I could travel 100 kilometers every day, could I reach the moon in 10 years? He is asking in 10 years traveling she can reach the moon if every day 100 kilometers travel. The distance between Earth and Moon is here given 3,84,400 kilometers. So she traveled in a year. One day 100 kilometers. So in a year means 365 days, that into 100. And in 10 years means this will get 365, that into 10. So we are getting 3,65,000 kilometers. So in 10 years, that means here in 1 year she can travel 365 and 2 zeros, that means 36,500 kilometers in 1 year. In 10 years it will become 3,65,000 kilometers. But the distance between Earth and Moon, that is 3,84,400 kilometers. Now she reached in 10 years only this much. So she cannot reach in 10 years, or she cannot cover this much distance. This we can write in sentence. Distance between Earth and Moon, that is 3,84,400 kilometers. Distance she traveled in 1 day, in a day, that is 100 kilometers. Distance she traveled in a year, in 1 year. So 1 year means 365 days, every day 100 kilometers. So 365 into 100, it will become 36,500 kilometers in 1 year. Like that way, distance she can travel in 10 years. So 36,500 into 10, it will become 3,65,000 kilometers. But the distance between Earth and Moon is 3,84,400 kilometers. This is more. So in 10 years, she will not reach, or she cannot cover this much distance. Next question. Find out if you can reach the sun in a lifetime if you travel 1,000 kilometers every day. So the distance between Earth and Sun, that is given in the previous page. The Earth and Sun here. The distance between Sun and Earth, that is given here 2,100 into 70,000, that much kilometers between the Earth and Sun. So we can take this measurement from there. And so the distance between Earth and Sun, we can write that as 2,100 into 70,000 is equal to 14 crore 70 lakh. that much kilometer. Now she is traveling 1000 kilometer per day. Every day 1000 kilometer. So time required, that means this divided by 1000, we will get 1,47,000 days. Per day she traveled 1000 kilometer. So when we are dividing by 1000, we are getting 1,47,000 days. These days we can convert to year by dividing by 365. 1 year is equal to 365. So when we are dividing, we are getting 403 years. So she is asking in a lifetime. Life year means 100 years. So it is not possible to reach the sun in a lifetime which is less than 100 years. Normal life human being, that is less than 100 years. So she cannot cover this 403 years. That much time will take to reach sun. So in a normal lifetime, not possible. So first we have to take the distance between earth and sun. 1 day 1000 kilometer, divide by that. So we will get this many days required. That number of days, again we are dividing by 365 to find how many years required. Here the question. Make necessary reasonable assumptions and answer the questions. First one. If a single sheet of paper weighs 5 gram, would you lift 1 lakh sheets of paper together at the same time? So 1 lakh into 5. You can write in sentence. 1 sheet contains 5 grams. So 1 lakh sheet means 5 into 1 lakh. It's equal to 5 lakh that much gram. So convert that gram to kilogram. So we will get that as 500 kilogram. We cannot take 500 kilograms. So write it there. We couldn't lift 1 lakh sheets. That means this 500 kilogram together. B. If 250 babies are born every minute across the world, will million babies be born in a day? 250 babies in 1 minute. So in 1 hour, we have to multiply with 60. After that, in a day, that means 24 hours. Multiply with 24. So we can look at the answer. Here, number of babies born every minute, that is 250. And then, total babies born in a day means that 250 in minute. That in 1 hour, 60 minutes. So multiply by 60 to get in 1 hour how many babies. And 1 day means 24 hours in a day. So multiply with 24 also. After multiplying all this, we will get 3,60,000. That means in a day, 3,60,000 babies babies only born. That not a million. Million means it will come more bigger number. So in a day, it will not come million. Can you count 1 million coins in a day? Assume you can count 1 coin every second. So this in second. Second we have to multiply with 60. It will come minute. Again multiply with 60. That will come hour. Again multiply with 24 to make that as a day. So we can break it this way. 1 coin can count in 1 second. So in a day means 1 second, then convert in 1 minute 60 coins. That into 1 hour. That into 24 hours, which means 1 day. So we are getting 86,400 coins can count in a day, not 1 million. Figure it out, page number 90. Using all the digits 0 to 9. Make the largest multiple of 5. So largest multiple of 5 by using all the digits. So we can write the digits in decreasing order from 9 to 0. So the number will be 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Last digit is 0, that will be a multiple of 5. So the largest number means write all the digits in decreasing order. Now here the smallest even number. Smallest even number, we cannot start a 10, it's supposed to be a 10 digit number. 2, 4, 6, 8, 10 digit. So we cannot start with 0. Smallest number means increasing order, we had to write all the digits. So you cannot start with 0, so start with 1, next smallest one, and then put 0. Then write all the numbers in increasing order. 2, 3, 4, 5, 6, 7. Now even number we have to get. Now the remaining numbers are 8 and 9. If we are putting 9 in unit place, it will become odd number. We need even number. So put 9 here and 8 at the last. So now all 10 digits, 2, 4, 6, 8, 10 digits are there. This is the smallest even number. Second question, the number 10,30,285 in words has 43 letters. Give a 7-digit number. Name which has a maximum number of letters. Maximum number of letters. So when we are looking the digits, we can see 0, 1, 2, 3, 4, 5. Maximum digit is coming for the number 7. S-E-V-E-N. So we can write a 7-digit number using all the digits as 7. That will come with the maximum number of digits. Here 77,77,777. So total it is coming, here it was 43 letters. In this example it is coming 61 letters. Longest 7-digit number. Third question, write a 9-digit number where exchanging any 2 digits results in a bigger number. How many such numbers exist? So a 9-digit number where exchanging any 2 digits results in a bigger number. So write all the digits in increasing order. So all the 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the number. How many such numbers are there? Only this number. Here when we are exchanging the number, any number when we are putting to this side, that will become bigger number. Now strike out 10 digits from the number so that the remaining number is as large as possible. So here we can see 1, 2 up to 5. It is repeated 1, 2, 3, 4 groups. And we can cut 10 digits from that. So when we are cutting 10 digits, we have to get the largest number as possible. So we can cut from here the first group 1, 2, 3, 4. 1, 2, 3, 4. Again 1, 2, 3, 4. Now here is 1, 5. Another 5 is here. Now we cut 4 plus 4, 8 digits. Now we can cut only 2 more digits. That means this 1 and 2. The remaining numbers or the remaining digits we can write it here. 3, 4, 5 and the next group 1, 2, 3, 4, 5. So now we can see this is the number after removing 10 smallest digits from left to right, and the number what we are getting, which is the large number as possible according to the question. So 8 digits we have to remove. So small numbers from left to, small digits from left to right. 4 digits here, 1, 2, 3, 4 again, and 1 and 2. Then fifth question. The words 0 and 1 share letters E and O. That means O is in both, E also in both the term. The words 1 and 2, the letter O. Here is O, in 1 also O. And 2 and 3. There we can see the letter T, common. How far do you have to count? Find 2 consecutive numbers which do not share an English letter in common. We are continuing like the same way. Everywhere we can see some letters 1 and 2, so O, 2 and 3, T, 3 and 4, R, 4 and 5, F, 19 and 20. There are many letters T, E, N. So there is no consecutive numbers that do not share a letter in common. Every consecutive terms have one or two many letters as common. Sixth question here 1, 2, 3, 4, 9, 10, 11, etc. The 10th digit you write as 1 and the 11th digit as 0. That means till here is the 10th digit, 11th digit, 12th digit, 13th digit, like the number of digits in the number. Then here the question, what would the 1000th digit be? At which number would it occur? 1000th digit. So we have to calculate in 1 digit number hit up to 9. Then in 2 digit number 10 to 99. So we can write in sentence. The calculation work it will come like the same. Numbers in 1 to 9, that means 9 digits. 1, 2, 3, 4 up to 9. Each with 1 digit number. So 9 digits are there. From 2 digit numbers 10 to 99. 90 numbers are there, each one with 2 digit. Here 1, 2, here 1, 2, like that way. So total it will come 180 digits. 90 numbers of 2 digit. It will come 180 digits. Now 3 digit numbers starting from 100 to 999. There are 900 numbers, each one with 3 digit. So the number of digits total it will come 900 into 3, 2700 digits. Now when we are looking this all, first we have to add 9 and 189. It will come 189. We need 1000th digit. So that number will be a 3 digit number. 9 and 180, that means 189 numbers are coming in 2 digit. 1 and 2 together. After that it is coming. The remaining means 1000th digit will be a 3 digit number. So to find that 1000 minus this 189. So 811 we will get. So 800 3 digit number. So the number, which number is coming into 811, that to find that 811 by 3. Each number is having 3 digit. So dividing by 3 we will get approximate 270. The 270th 3 digit number. So 3 digit number, the 270th 3 digit number. So from 1, 2, 3 etc. we have already first 1 digit and 2 digit together 100. That 100 plus 270 numbers more. So it will come 370. So 370 is the number which has 1000th digit is coming in that. And 3 is that 1000th digit. So 370 is the 1000th digit and in that number, and 3 is that digit. B. What number contain millionth digit? So lengthy calculation work. The millionth digit in which number it will come. So same way we can do that. The number of digits in 1 digit number, 9 digits are there. 2 digit numbers from 10 to 99. 2 digit number, 90 numbers are there. So 180 digits it will come. Then 3 digit numbers starting from 100 to 999. Each number with 3 digit, like that way 900 numbers. So total number of digits it will come 2700. Now 4 digit numbers from 1000 to 9999. 4 digit numbers, 9000 numbers are there. So total 36,000 digits it will come. Now 5 digit numbers from 10,000 to 99,999. 5 digit numbers, 90,000 numbers. So it will come 4,50,000 30,000 digits. Now 6-digit numbers from 1 lakh to 9,99,999. 6-digit numbers like that way, 9 lakh numbers, so it will come 54 lakh digits. Now we have to calculate till here. Number of digits in 1 digit, 2-digit numbers, 3-digit numbers, 4-digit numbers, 5-digit numbers. When we are calculating up to 5-digit numbers, we are getting 4,88,889. So the millionth digit that will lie in a 6-digit number. We calculated till here. The remaining it will come in 6-digit in between this. To find that million, 1 million minus this sum. So we are getting here 5,11,111. That means when we are minusing from 1000 all the 5-digit numbers, we'll get this one. Now the number is coming in a 6-digit number in this group, 6-digit numbers group. So to find which number, we have to divide by 6. So you will get approximate 85,185. So 85,185th is the 6-digit number. In that number it will come. So till there, all from 1 digit to 5 digit, we have already 1 lakh numbers. That 1 lakh plus this number, it will come 1,85,185. So the millionth digit occurs in the number, in a 6-digit number, 1,85,185. Now see, when would you have the written the digit 5 for 5,000th time? That also calculation work the same way. Now we have to check how many times 5 is coming, not the number of digits, number of times 5 is occurring in that. So in between from 1 to 9, 5 is coming only one time. 1, 2, 3, 4, 5, that 5 only one time. From 10 to 99, there are 19 times, which means 15, 25, 35, 45, like that way up to 95, 9 times. Then 50, 51, 52, that means in tens place. So 10 times will come. Total 19 times. Same way in 3-digit numbers, 100 to 999. In unit place, 90 times it will come. In tens place, this is the unit place, this is the tens place, like that way. Here hundreds place, that means 500, 1, 502, like that way. So there it is coming 100 times, total 280 times. Now in 4-digit numbers, unit place 900 times, tens place 900 times, 100 place 900 times, and 1000 place 1000 times, total 3700. Now in between 10,000 and 10,999, there in unit place 100, tens place 100, hundreds place 100, 300 will come. 11,000 to 11,999, there are also 300. 12,000 to 12,999, 300. Now when we are adding, it's almost it's coming close to 5,000. So next we have to take from 13,000 to 13,999. We are considering only unit place. We are not considering tens place. That means 13,005, 13,015, like that, a unit place only we are taking, not the tens place or hundreds place or thousands place. So when we are adding all this, that means here 1, 19, 1, 280, 3,700, 300, 300, 300 and 100. Altogether it will become 5000. So the 5000th time, so when we are adding all this, we are getting here the total as 5000. So the 5000th time 5 occurs. That means in the number 13,995 here. So in the question, a calculator has only 10,000 and 100 buttons. Write an expression describing the number button clicks to be made for the following numbers. Here 20,800. We can make that a 2 into 10,000 plus 8 into 100. So we can write in this 2 into 10,000 and 8 into 100. So 2 plus 8, 10 clicks only that is coming. Next number 92,100. So 9 into 10,000 and 21 into 100. So 9 plus 21, 30 clicks. Next 1,20,500. So 12, 10,000 button, 12 times. 5 times 100 button. So total 12 plus 5, 17 times. Next one 65 lakh 30,000. So 653 times 10,000 button. So the 0 button no need because we are all zeros. So 653 times. Last number 70 lakh 25,700. For that 702 times 10,000 button and the remaining 57,100 button. So when we are adding, total it is coming 759 times or that much click. Here 10,000 buttons. That means we have to take the 10,000 ones, tens, 100,000 from here. This was with the 10,000 button and the remaining with the 100 button. 100's place you have to remove that much 100 button or this much 10,000 button. That's the way it easily we can write. Question number 8. How many lakhs make a billion? We know that 1 lakh into 10,000 is equal to 1 billion. So 10,000 lakhs make a billion. So you write billion and then lakh. And check that the number of zeros. Here for lakh 5 zeros, but for billion 9 zeros. So we need 4 zeros more. That means 10,000. So 10,000 lakhs make a billion. And the question, here the number cards from 1 to 9. We have to make the largest possible sum and also the smallest possible difference of the two resulting numbers. Here they have given two sets of number cards from 1 to 9. So to get the largest number, we have to write the largest digits, 2 set. That means 2 times 9, 2 times 8, 2 times 7 and then 1 times 6. Then the remaining number. Here that second set, 2 times 5, 2 times 4. So the largest possible sum we will get, that is 1,54,320. Same way to find the smallest possible difference. Here we have to write just opposite, the smallest numbers, smaller digits. 1, 1, 2 sets are there. So every digit with 2 times. 2, 2, 3, 3, 4. That minus. So to find the smallest possible difference, so the number that minus the bigger numbers. So second number is supposed to be the bigger one. 8, 8, 7. So when from a smallest number, when we are subtracting the biggest 5-digit number, we will get here 10,22,447. This is the smallest possible difference. 10,22,447. Two sets are there, so write that way. 10th question here. You are given some number cards 4,000, 13,000, 300, 70,000, 1,50,000, 25. Using these cards close to you can to make the numbers below. Here the one example is 1,10,000. So 4,000 into 20 plus 5 plus 13,000 we will get the number. So similarly we can write the next number, that is 2 lakh. So 2 lakh we can write as the biggest number is here given 1,50,000. So that we can take 1,50,000. Then 70,000. You can use any calculation work here. Using the cards, so you can use any operation you want. So 70,000, then minus 4,000 into 5. 4,000 into 5, it will come 20,000. When we are minusing, it will come 50,000. And when we are adding that to, we will get 2 lakh. So here the condition, only one time that we can use it. Can be used only once. That's why we are taking like this way. 4,000 into 5, 20,000, that we have to minus from there. 20,000 is not in that card. Next number, 5,80,000. For that, 70,000 into 5 plus 1,50,000 and 4,000 into 20. When we are adding, we will get exact 5,80,000. Next number, 12,45,000. For that, 70,000 into 20, that minus 1,50,000 minus 4,000 minus 300 into 5. Then only we will get 12,44,500, which is almost close to 12,45,000, not getting exact one. The last number, that is 20,04,000. That we can write as 13,000 into 300 minus 70,000, that 20 plus 5 times 25 times minus 1,50,000 plus 4,000. So we will get 20,04,000. Find out how many coins should be stacked to match the height of the Statue of Unity. Assume each coin 1 millimeter thick. So we know the height of the Statue of Unity, that is 180 meter. 180 meter, when we are converting to millimeter, it will come 1,80,000 millimeter. Multiply with 1,000. Thickness of one coin is 1 millimeter. So to match the height of that statue, we need 1,80,000 coins. That much millimeter, each coin with 1 millimeter. So we need 1,80,000 coins to make the height same as that. 12th question. Gray-headed albatrosses have a roughly 7 feet wide wingspan. And across the several oceans, can cover about 900 to 1,000 kilometers in a day. One of the single trips recorded 12,000 kilometers. How many days would such a trip take across the Pacific Ocean approximately? Here if they are taking 900 kilometers per day, this distance to cover 12,000 by 900 will take 13 days. If they are traveling 1,000 kilometers in a day, so 12,000 divided by 1,000 we will get 12 days. So it will take 12 to 13 days to complete that 12,000 kilometer trip. Here the question, a bar-tailed godwit holds the record, longest record non-stop flight, traveled 13,560 kilometers from Alaska to Australia without stopping. Its journey started 13th October 22 and continued for 11 days find out approximate distance it covered every day. So the total distance is this one and total time taken 11 days. So just you divide by 11, we will get approximate distance covered in a day. You can write that distance covered every day, that is total 13,560, 11 days. So we will get approximately 1233 kilometer in a day. Then in every hour, here the question, we have to find out approximate distance every day and every hour. So every day we got 1233. Now every hour, in one day means 24 hours. So divide that by 24. 1233 by 24, we will get 51 kilometer per hour. So Godwit covers 51 kilometer per hour approximately. And 1233 kilometer per day. So total distance by number of days. We will get in one day how much it can travel. Then in 1 hour, again that by 24. 1 day is equal to 24 hours. 14th question. Bald eagles are known to fly 4,500 to 6,000 meter above ground level. Mount Everest is having 8,850 meter height. Aeroplanes can travel 10,000 to 12,800 meter high. How many times bigger are these heights compared to Somu's building? Somu's building, we know that is each floor with 4 meter, 11 floors, so 44 meter tall. So bald eagle, that is 4,500 to 6,000. So compare with the Somu's building, we had to divide by 44. We are getting 100. 4,500 by 44, we will get 100. 6,000 divided by 44, we are getting 150. That means bald eagle's flying height is 100 to 150 times bigger. Now compare with Mount Everest. Mount Everest height is 8,850. Somu's building height is 44. Divide. We will get 201 times bigger. That Mount Everest is 201 times bigger than Somu's building. Now aeroplane's height. 10,000 divided by 44, it will come to 30, and 12,800 aeroplane is traveling in this range. So that by Somu's building height, 290. So we can write aeroplane's flying height is 230 to 290 times bigger than Somu's building. So each case we are comparing with the Somu's building. So we had to divide the height of the aeroplane or Mount Everest or whatever that by Somu's building height. So it will come 230 here. Aeroplane's flying height is 230 to 290 times bigger than Somu's building.